So for our second example, we have that the mean room and board expense per year at four-year colleges is $10,453, where you randomly select 9 four-year colleges and want to find the probability that the mean expense is less than $10,750. I really hope none of you guys are spending that much money to live at the FGCU dorms, especially not this year, but anyway, we're going to assume that these are normally distributed with standard deviation 1650. So in this case, again, note carefully we're talking about a mean. And here we do have that n is equal to 9, which is technically speaking too small for the first case of the central limit theorem, but the population is normal, not ignormal. Get a little bit closer. So the central limit theorem still holds, just for different reasons. It's in the second case rather than the first. And as a result, we can then talk about what's going on here in terms of our mean of sample means, mu sub x bar, where here mu sub x bar is going to be equal to 10,453, and sigma sub x bar, our standard error, is going to be 1,650 divided by the square root of 9, which here, hey, it's a perfect square, and it divides in nicely. So this is one of those rare cases where the rounding actually does work itself out, and we get a nice number. But from here, it's also probably a good idea to get a sense of roughly what it is that we're trying to picture here. It's always a good idea to just make a nice sketch for yourself with these distributions. Here, it looks a little bit funky because you got a slightly different thing in the middle, but it's the same sort of idea, the same sort of area that we're looking for. Where to be sure, we can convert that to a z-score. We can get that z is equal to 10,750 minus 10,453 divided by 550, or about 0.54. But really, that's only if you want to use the table, so I'm not going to write it out. Instead, we're really just trying to find the probability that x bar is less than 10,750, which here you can follow through with a normal CDF type computation. And what you will get for that is that the probability here, excuse me, back and forth in my notes, is about 70.54%, about 70.5%. We're going to get one more here with these same sort of ideas, but just to really see how this stuff goes, we're actually make a comparison between what happens if we think in terms of the central limit theorem and if we talk more generally in terms of probabilities.